If I drive my car into the river and it implodes, what will be the volume? So for this gas, for this one, what's the first one we did? We did pressure and volume. We did pressure and temperature. So now we have to do volume and temperature. So it's probably 5 is already done. So let me do a different problem. Okay, problem 3. Because I want to emphasize all 3 equations. So now we're going to keep constant pressure and constant moles. So there's only 4 types of problems. I have done 3. This is the 4th one. Constant pressure and constant moles. Okay. So it's V1 equals V1 over T1 equals V2 over T2. You do not have to memorize these equations, but again, you have to know
which
equation to use based on the question given. So if you go to number 3, it says if 15 liters of neon gas at 25 degrees are allowed to expand to 45 liters, what must be the new temperature? So here's the way I would do any of these problems is liters is volume. So I know V1 is given, 15 liters. T1 degrees Celsius is a temperature unit, so 25 degrees is given. It is expanding, so the initial part of everything is at the first part of the equation. Whatever's final is the T2 part, which comes towards the end of the question. That's the way a chemistry question is written. So that can be changed. I won't trick you, let me be honest, because there's no point in tricking here. This is not a magic class. And what must be the new temperature to maintain constant pressure? Now this is a tricky question. I won't, it's not a tricky question, it's tricky because I didn't write this one.
Is that 15 or 150?
15.
Okay.
Now constant pressure means I will give you an actual value. I don't expect you to do this. Constant pressure in chemistry means it's 1 atm. Oh, constant pressure, sorry. That means we're not even solving for it. So I was right. So it's expanding to 45 liters. So 45 liters. And you're asked to find the new temperature. The question states pretty clearly what you have to calculate. Now this is, everything I teach, I have learned it from experience. So this is foolproof. You're not going to get the problem wrong. The only way you're going to get it wrong is you make it complex on yourself. That you put in a lot of constraints that you don't need to. This problem is simple. It says the initial volume is 15 liters. Initial temperature is 25 degrees Celsius. And the gas expands to means it is at some other volume. And it's asking what is the new temperature. The question is very simple. As I said, the only time you do have to make conversions is for temperatures. This you don't need to, but this must be converted to Kelvin.
Kelvins.
So degree Kelvin is degrees Celsius plus, again, this equation will also be on the first page of the test. So you don't have to memorize these equations, or the constants will be given to you. Okay? Only thing you have to do on your part is
298.
298 Kelvin. So that means we know V1 is 15, T1 is 298, V2 45, T2 we don't know. What is T2? Can someone tell me what the value for T2 is? If you're wondering how you would solve it, it's 298 times 45. Really? It's 894? What do you get?
894.
Okay, then that's the answer. Isn't that big number? Yeah. 298 times 45 divided by 15. Whatever answer you get is the answer. There's no need to do anything more. So those are the 3 types of problems that I will give you. If you have these equations written down on your notebook, from here you just have to do the calculations. Again, when I gave this homework, I haven't taught the material, so I didn't expect any of you to solve any of this. Now we have the last piece of puzzle that I want to do. Just 2 more simple problems, and we will be done with our exam material, and then next Wednesday we can just meet and have just a QA session. I'll try to come up with some kind of sample exam so we can all work together as a class, so that way if you have any questions you can ask me, rather than having a blue ball surprise on the exam. All right, let's go to. There are two types of concentration. Again, I will write my facts here and do the math on that side. Concentration, if you have come to this class and if you can't learn it, that would be a crime on my part. Because as a nurse, at least minimum you should know this. And knowing those practical things like the pressure volume, it's just important to have a general knowledge of the book. But if you have come to my class and you didn't learn this, that's a big crime on my part, and you just wasted your money. And I don't want you to waste your money. There are two types of concentration. One is called molarity, the other is called molality. Please make sure you don't pronounce it the same. I probably am screwing up it already. This is uppercase M, this is lowercase m. One is called molarity, one is called molality. Now molality is not really used in our daily life things. If you don't take anything from my class, at least if you could learn how to do molarity.
You say that all the time.
What's that?
If you don't take anything from my class.
Right.
Because I want to give you some hope that you're going to learn something from it. And if I tell you this is hard every time, then you say, well, then I am not going to learn it. Right? At least, like I said, molarity is important because as a nurse, you should be able to make sense of that number when it is given in molarity. It would be ridiculous if you cannot, talk to a doctor and he says, give a 2 normal intravenous solution to this patient. You may not have a 2 molar solution on stock, but at least you should know, oh, let me grab a 4 molar, take it to the pharmacist, he can dilute it to me for 2 molar.
Right.
I don't. It's like our kids.
It is important that you learn that way, okay? So let's understand what this molarity means.
We show up saying that, they're going to be like, what?
What are you talking about?
We just type it in and it tells us everything.
Okay, we're only going to learn one problem from here, one problem for that, and I will not trick you in any ways to make life harder for you than it already is. So molarity is expressed as moles of solute. Oh, before, I will leave you with one question before I go further. Would water boil, that was one of the PowerPoint slides I had. You can find out the answer the next time you come. Would water boil faster at high altitudes, or would it boil slower? Would it be faster to boil water on top of Mount Everest, or would it be slower to boil water on top of Mount Everest?
Slower because it's cold.
Get the answer for me the next time you come. Okay? Molarity is expressed as moles of solute over, because it is not that straightforward answer. This is why I'm telling you to Google it up. Go to a reliable source, get a reliable answer. Okay? It is not simply about speed of something, it is much more than that. But I want you to know it because some of you may decide to go hiking at high altitudes or
No, I'm
skiing.
We're not
good.
going there.
You're not going there either?
No.
All right.
Did you see that movie?
Which one?
Everest.
I was bored.
Definitely
I've
not
seen
one.
it.
It's
was
really
crap.
good.
It was crap.
I thought it was good.
It got no story, no screenplay. It was just,
The story is them climbing the mountain.
it's like, I don't know how many of you have been to Singapore. Anybody here been to Singapore?
Yeah, right.
Okay, if you go to Singapore, don't go to their McDonald's. That's the tip I can give you. If you're planning on going to Singapore, just don't go to their McDonald's. I made the crime of going to their, I don't go to McDonald's, but it was airport and I was hungry. They like steam their burgers. They don't actually grill and then put it in a hot area. They actually like steam, like how you would steam a rice. That's how the McDonald's patty is cooked. And it's ridiculously blunt. And that's what I felt when I watched that.
No spices? No spices?
No, it is not how it's done here. It looks complete like how you'd steam a rice, like you would put steam bath and put the patty on top. So they steam the So it doesn't
Oh, yeah,
naturally
no
extract
flavor.
that greasy flavor you get from a meat. It tastes pathetic. I took only one bite, just threw the whole sandwich and for this I had to actually go get, back in those days, we don't have Visa that popular, so we had to go to the airport currency conversion place, give my US dollars, get Singapore dollars, just to get that food, so I'm hungry, and the food really killed my appetite.
You should have told them to give you your money back.
Well, they're not going to give you money back. All right. So molarity is nothing but moles of solute over. Now I want to make something clear here. You all heard the word solution. You probably even heard the word solvent.
Mm-hmm.
A solution is a combination of a solute plus a solvent. It's important that we understand this simple concept. A solution is a combination of a solute and a solvent. Solute is usually in tiny quantities. I don't want to write any chemistry here, because this applies to even daily life. Solute is typically in tiny quantities. Solvent is typically in large quantities. You cannot flip it as the other way around. Then you have a problem at hand. Okay. So this coffee, the solvent is actually the coffee. Okay, the actual coffee itself, the black coffee, is the solvent, because that's the majority of it. They leave a little room for cream and sugar. So your cream and your sugar, anything you put in small quantities is your solute. Anything you put in large quantities is your solvent. So this coffee was purely black. Almost 98% of it was just black coffee. That was the solvent, and then I added a little bit of cream and sugar. And that is the solute. Okay. It's important you remember that, because you're going to get these confused. So let's actually solve a problem. That's the only way to help you understand the questions. I'm going to actually do maybe one or two problems from the homework. And the reason I'm using the homework is because I have not taught this concept before, and I don't expect you to do the homework before. So let's go to problem number 11. Okay, I'm going to write the actual question because it is actually simple, right? What is the molarity? Keep in mind it's molarity, not molality. They sound very similar. Molarity of the test question might have the similar format too, so you don't need to do anything different than how you are going to do the homework. I'll give somebody a good chocolate cookie next time if someone could tell me the name of this. What's the name of this? We did naming compounds. What's the name of this compound? I know that's 2 weeks old material, right?
Yeah. Sodium bicarb?
Sodium nitrate,
No, it's sodium.
bicarbonate.
Nope. Hold on, I'm gonna tell you.
You were close. First time you said it right, and then you see
Sodium cobalt?
No.
It-
It is sodium carbonate, right?
Sodium carbonate.
yes. Definitely.
Remember that swapping carbonate was CO3 2 minus. Sodium is an alkali metal, Na1 plus. We swap, we got Na2CO3. I know this is 3 weeks old, but that's okay. We are going to review all this next week. So, because that what really doesn't happen in a typical chemistry classes. The professor teaches continuously until that day before or the week before the exam. There's no room for review. Students learn all these massive complex concepts one after the other, and then right away there's a test. They're like, okay, I learned that, I understood it then, but wish you had done a review then, I would have remembered it. Which is why we're doing 3-hour review, which will bring you all back to the reality of what will be on test. So this is sodium carbonate. We did this. We were all experts on that homework at one point in time. Now we have to calculate molarity. Now if you write that, whatever in words back there, we want to calculate moles of solute. Oh, I didn't complete the question. In 400 milliliters solution. Okay? molarity is moles of solute over, I guess, volume of solution. In this case, we can assume safely that this was dissolved in water, even though that information is not needed. You do not need to know what it is dissolved in. Usually it's water. So this is your solute, because it is given in grams, and it is 5.3 grams is really small compared to 400 milliliters. So that's your solute. This is your volume of the solution. It's already saying the word solution. So and the unit is moles over